Good morning, my name is Saja Alrawahneh. I'm a PhD student in Okan University. First year here, I'm having a course of sustainable and green building. For today, I'm going to present my article, which is about the ecological evaluation of high-rise building and density of our hot climate weather. Under the supervision of Professor Halil Samih Rialdis. We will start by the abstract. Carbon emissions become one of the most important issues as the world moves toward sustainability and carbon-free future, in addition to the increased demand on the vertical construction movement because of the high density and economic factor. It was important to ecologically evaluate the current status of the existing building. The study analyzes the features characteristic in order to explain how can we embrace sustainability and green building strategies to reduce the ecological footprint in the dense city. Therefore, by applying an ecological strategies for the systems will protect the nature resources of energy, water waste, and carbon emissions reduction with compensation the addition cost in a few years. We can define ecologically as the relationship between living organisms and their environment. Also, in order for something to be ecological, it had to tend to a benefit or cause a mineral damage to the environment for something to be ecological. But our built environment unfortunately didn't apply the ecological concept, which led to a huge negative impact on our planet. Therefore, the ecological footprint (EF) monitor emerged to measure and maintain balance. In the beginning of 19, William Rees and Matthias Wickenregel proposed the ecological footprint analysis as the ecologically footprint (EF) as a given population is the ecologically productive land or sea areas required to reduce. In the figure below, we can see the world map of the EF for different countries, and the Middle East has a huge defect impact. Despite the harsh climate, this percentage must be reduced in order to ensure our survival in the future. And a good example on that was the United Arab Emirates, which reduced their footprint from 11.8 in 2006 to 8.3 in 2016. Even their demand on high-rise building increases, they managed to reduce that percentage. For the high-rise building demand and necessity, therefore, in this study, I'm focusing on defining the main ecological characteristic of building because they represent a big percentage of our ecological impact, especially high-rise building, which their height is more than 150 meters. Because of high-rise building is the main element in any modern cities nowadays, particularly after the industrial and the petrol revolution in the Arab Gulf area, which offered changes to the construction condition, regrading, vitality usage, structure, performance, and waste management. To improve this, there was a further study by Dr. Anthony Wood, Executive Director of the Council of Tall Building and Urban Habitat, which says dense downtown versus suburban dispersed, a pilot study on urban sustainability. Not only considers the building as a stone land element, but include other factors such as the infrastructure requirement, roads, utilities, and the energy impact of transport. In addition to the other things, the examination shows that low-rise rural improvement can require up to 5 to 10 times the street and the vitality framework as a tall building. In this way, while high-rise is an independent arrangement, have an intrinsically highly empathize vitality. Skyscraper can be a piece of a general progressive manageable arrangement which consider is more extensive setting. However, as an industry, we must also change ourselves to make a standalone high-rise more sustainable and part of the solution to the resource and the climate crisis. In this slide, we will be discussing the four main essential strategies in order to apply the ecological principle into high-rise building. Despite it can be also compared to the design of aircraft in terms of scale and integrated system and complexity of design and construction. The main characteristic that define the building is construction and use material impact on the environment, energy efficiency, waste management, emission reduction. Mainly, construction and use material impact on environment is discussing one of the most effective technique is using the pre-assembled unit prefabricated in a controlled offset condition. This will make less expensive on the grounds that it fundamentally diminishes development times by empowering development and building difficulty. Also, it will lower the air contamination and the CO2 emissions. Also, elective eco-friendly materials that have similar ecological footprint also will be better solution for such a case. Recycled material is a key factor like steel, cement and glass. All things considered should be the vitality expected to warmth and cool these high-rise buildings isn't just expensive yet additional harm nature by creating enormous carbon dioxide. In the case of energy efficiency, another approach that my high-rise building increasingly maintainable for an incredible duration cycle is to improve the energy proficiency. Since nature does everything on schedule and there is no though nature is a motivation for a native and keen building. Constantly, we can diminish tall structure natural sway by getting a motivation from nature, gave biomimicry principles being incorporated into the design. Also, developing a renewable energy resource within the design increase the efficiency of the building. In the case of waste management, waste broker market development managers say recycled steel reduced mining waste by 97%, air pollution by 86%, and water pollution by 76%. Producing steel through outside recycling also uses significantly less energy than conventional steel making. The typical metal building is manufactured from at least 70% recycled steel. In addition to develop a dispose technique for the building life cycle waste integrated within the system, demolishing phases and building ruins. In the emission reduction, building accounts for 40% of the world's energy resources, 36% of the energy-related carbon emission in industrialized countries. It is necessary to be included for interpretation of CO2 emissions calculation. In this part, we will be discussing a few cases that applied a part of the previous characteristic in order for a high-rise building to be ecological. And those cases were from Al Manama City, Abu Dhabi City, and Dubai City. For further more detail, we will start with the first one. The first example is Al Bahr Tower, Dubai, in the United Arab Emirates. The architect is ADIS, and the consultant structure engineer design is Arup Company. It was ended in 2012. The design main concept was based on the fusion between the bio-inspiration, regional architect, performance-based technology, and as you can see in the picture, there are a few more information. And the design element for the project is so simple cylinder because the circular plan giving the most efficient floor area usage while also create the greatest volume with the least surface area, which will highly reduce the sun exposure surface area. Also, the design is based on the concept of adapting flowers and the mashrabiyas, a wood lattice shaping screen, a dynamic and sensitive shading screen acting as a mashrabiya. Second, this can filter the light and reduce the glare. You can see in this we're showing the material used and also the biomimicry ideas that were applied in such a case. In the upper part you can see the photovoltaic cells, the roof facing south. Each tower incorporate photovoltaic cells, generating approximately 5% of the total energy required for renewable energy resource for the heating water. The tower have been one of the first building in the Gulf area that received a LEED Silver rating. Efficiency, which the tower were awarded in 2012 Tall Building Innovation Award. The quantitative benefits: 50% energy saving for office space alone and up to 20% for the building overall. 20% reduction in carbon emission up to 50% for office space use alone. 15% reduction in overall plant size and capital cost, 20% reduction in material and overall weighted due to the highly fluid, rational and optimized design. The second case, Alrawahneh World Tower Center, which is located in Al Manama, designed by W.S. Atkins, finished and completed in 2008. It was inspired by the shape of the sails of ships that used wind energy to surf, like the WTC uses wind energy to supply the need of the activities taking place inside it. The two towers are joined by 3 bridges that support each of the 3 wind turbines erected at the project. All the buildings were designed to optimize the passive wind through the area where the turbines are placed, increasingly its natural rate up to 30%. In the case of this World Trade Center, the plan was carried out because the conventional design supports 3 windmills, 29 meters in diameter each, to make a minimum vibration and noise. The budget required to be devoted to scientific research was minimal. Also, the 3 windmills running to a full capacity can provide between 11 and 15% of the energy the building demands. This building is not intended to be a low carbon emission solution. Aside from the wind turbine, it does include a number of other features that summarize as you can see below. Those are further detailed on how this building apply a low carbon emissions through the design process. You can see as in the figure below. The project energy yield from the turbine taking into account the wind and the availability data is summarized below. This amount is between, as we said before, 1100 1300 megawatt per hour per year. The third example is at Dar headquarters in Abu Dhabi. It is designed by MZ and partners, Marwan Zoaib Engineering and Engineering Aruj Group. Year of construction 2010. It also have a silver lead as a green building. This is the project had challenge of the construction approach by questioning the typical structure of the roof. This building based on 3 side zipper elements as a third hanging a continuous structural glass band continuing the 2 main front, creating a thin continuous surface that is both horizontal and vertical front and side windows and roof. Also, the materials are mostly recycled glass, steel and concrete. During the construction of prefabricated elements were used to reduce the waste. The project also adopted a system of underground vacuum waste collection waste that transfer dirt to waste transfer station for recycling and compacting, eliminating the need for collection vehicles, including the district cooling plants, as well as effective light and water system. The building efficiency is classified as 82%, making its most efficient design for the floor area. This is the conclusion. This paper presented the current status of available high-rise buildings which can be considered as ecological based on their applications because of our urgent need to reduce the ecological footprint in hot climate. Also, few results were found in order to reduce the ecological footprint through some application. There were found through study 3 proposed cases from the hot climate region as shown in the table below. But the research had some limitation, which is inability to generalize the results because of the lack of information resource in addition to the climate specification.